using bond energies. It's one of my favorite methods, but the thing you have to do is draw the structures of these molecules, which we talked about. Like most of them, you should know. So CH4. Pretty simple. Worked with this last year, working with it this year. So it's basically just calculating all the bond energies and then looking at the difference between them. We have 1O2. Looks like that. It's a double bonded. Should know that. CO2 is a carbon double bonded to 2 oxygens. And then H2O. Those are your structures. Do we have, but we look, we have 2 H2Os, so we have to draw both of those. So those are all the bonds that we have. And I like to just like draw this little arrow there. So on a chart, which I think I gave to you, let me see. Yes, there's the chart. So I'm not going to open that chart, but I'm going to refer to that chart. All right, so if I go back to this equation, I have 4 CH bonds, and each one has a bond energy of 413 kilojoules per mole. Again, I'm not going to write those units in because I'm running out of room. So if I multiply 4 times 413, I get 1,652. All right, now I have 1 oxygen bonded to oxygen, and that's 495 kilojoules per mole. So that 495. So now you need to remember that with bond energies, that's the energy required to break a chemical bond. Bonds, when you break bonds, you have to add energy to them. Sometimes student thinks that that's when energy is given off. It is not. Energy is added to break a bond. So this amount of energy is being added to this reaction. All right. Now, when the bond is reformed as a product, that's when energy is given off. So in this case, we have 2 CO bonds. Each one is 799. And then we have we have 4, 1, 2, 3, 4 HO bonds. Each one of those is 467. So if I do my math here, I get 1,598. Okay, so 4 times 467, I stopped there for a second. You just didn't know it. All right, is 1,868. Total that up, and I get 3,466. So that means it took 2,147 kilojoules to break the bonds, and then 3,466 kilojoules were given off when we reformed the products. So now to find the total enthalpy, it's going to be 3,466 kilojoules. Basically, it's going to be the products minus the reactants. But you got to, this is one of those you have to always think about what's going on. Energy is being given off. So, and when you subtract this, you get 1,319 kilojoules. That's how much energy is given off by the combustion of 1 mole of methane. So kilojoules per mole of methane. But you always have to think about, is it being given off, or is this endothermic? Is it taking more energy to break the bonds than is given off in the end? And then it's an endothermic reaction. Okay, homework on this one. I want you to, you might have to look up this structure, but I want you to do the bond energies for this. Don't forget to balance it before you draw out all the bonds. Okay. Okay, we can go through this. Last section. A lot of different symbols that you're going to see. And I want to just write what they are. Delta HF. This is standard heat of formation. This is heat of vaporization. And that is liquid to gas. This is heat of condensation. So condensation is gas to liquid. Okay, heat of combustion. We just talked about that with when we're doing the methane. This would simply mean the heat of the formation of CH4. You could write it there. Delta H, FUS, is the heat of fusion. That stands for fusion, and it is basically melting, which is solid to liquid. This would stand for the heat of solidification, and that is going from a liquid to a solid. Heat of sublimation is going from a solid to a gas. Heat of solution is when you dissolve something. And heat of reaction is what we've been working on, the entire reaction, like Hess's law. Okay, the last thing I want to talk about really quickly are just some graphs.